plus 3, here it is plus 4, the oxidation state of nitrogen in all these molecules, oxidation state, here it is plus 5. So, this is called nitrogen 1 oxide, nitrogen 2 oxide, nitrogen 3 oxide, like that. Among them, these two are neutral oxides and all others are acidic oxides. How do we know that a large number of oxides are acidic or basic? This is a simple question and the answer is over for this question. But it is not enough. We should be able to talk about all oxides. There are many oxides. So I once again will give another procedure for that also. This is it. Very few in our syllabus are neutral oxides. Very few, I repeat, in our syllabus. Neutral oxides. CO, carbon monoxide, NO, N2O, H2O. Only these four are neutral oxides. Just 4 neutral oxides in our syllabus. Neutral means they are neither acidic nor basic. They don't react with either acids or bases. And very few are amphoteric oxides. Amphoteric oxides. They are all the oxides of beryllium, aluminium, zinc, stannum, lead, arsenic, antimony, even gallium, and all the oxides of the following and TeO2. These are amphoteric oxides. What do you mean by amphoteric? Both acidic and basic. They react with both acids and bases and they form salts with them. Neutral oxides, they don't react with either acid or base. And these are amphoteric oxides. When I said all the oxides, what do I mean by that? All the oxides mean SN forms 2 varieties of oxides like SNO, SNO2, monoxide, dioxide, PbO, PbO2. Arsenic forms a trioxide, As2O3, As2O5, Sb2O3, Sb2O5. So considering them, they form several oxides, 2, like this. So all those oxides, and with tellurium it is only TeO2. We can't say anything about TeO3. TeO3 I don't know. So all other oxides, all the oxides of these are amphoteric. 3. All other metal oxides are basic. You know, metals are generally characterized by calcium, magnesium, aluminium, etc. But of course, aluminium oxide is amphoteric. So that's why I said all other metal oxides, the metals which I have mentioned here, you already know they are amphoteric. Other metals, you have aluminium, zinc, stannum, lead here. So all other metal oxides are basic. Magnesium oxide, basic. Calcium oxide, basic. Sodium oxide, basic. So all other metal oxides, most of the metal oxides are basic. And all other non-metal and half-metal oxides, all other non-metal, half-metal oxides are acidic. I repeat, there can be some exceptions, 1 or 2 exceptions, but these things broadly will satisfy our needs, whatever examination needs we have, these are more than enough. Suppose someone may tell you one of the oxides of chromium is amphoteric and one of the oxides of iron is neutral oxide, but all those oxides, they are not under our jurisdiction. We are just broadly discussing the main. So CO, NO and 2O, just 4 of the oxides are neutral. And these oxides are amphoteric and all other metal oxides are basic. Now what can you say about calcium oxide? Calcium oxide, metal oxide, basic. It's a metal oxide, basic. Magnesium oxide, once again, magnesium oxide, metal, basic. Nitrogen dioxide, NO2. What can you say about that? Nitrogen dioxide, non-metal oxide, acidic. Nitrogen dioxide is an acidic oxide. Sulfur dioxide, once again non-metal oxide, acidic. CO2, carbon dioxide, non-metal oxide, acidic. What about NO, nitric oxide? You already have that in this neutral list. NO, nitric oxide is neutral. What about zinc oxide? Zinc, of course, is a metal, but it is there in the amphoteric list. Oxide of zinc is amphoteric, though it is a metal. So there is no rule that something should be a metal, something, and it should be a metal oxide. So this is it. This is the broad rule. You just remember the 4 neutral oxides and a set of amphoteric oxides, a small closed set of amphoteric oxides. You don't have many elements here, 1, 2, 3, 4, 5, 6, 7, 8 roughly. You just have 8 elements whose oxides are amphoteric. So just don't need to worry about, just remember these 8 and remember these 4. Barring these 12, most of the metal oxides are basic, non-metal oxides are acidic. And in the first or second question, perhaps I discussed you which are non-metals. Only a handful of them are non-metals. Chlorine, bromine, iodine, etc. Very handful of them are non-metals. So non-metal oxides are acidic. So this is about acidity and basicity of all the oxides. Actually, the original question was about just nitrogen dioxide. We were just discussing nitrogen dioxide, but discussing a particular oxide or a particular element or a particular reaction doesn't tell you the whole story. We should never learn chemistry in bits and pieces. You should look at the whole picture. It's okay that you learn that nitrogen dioxide is acidic, nitrogen dioxide has this properties, that properties. But how are you going to learn about a large number of things? Only by looking at the whole picture. This is what the aim of the lecture. Next question. What is the oxidation state and covalency of phosphorus in P4? What is the oxidation state and covalency of phosphorus in P4? What do you mean by covalency? Number of bonds formed by phosphorus. Each phosphorus, in fact, you have 4 phosphorus atoms there, and we are interested in the number of bonds formed by each phosphorus. So the structure of P4 is actually like this. You just draw 3 phosphorus atoms in one plane. This is P3 in fact. The 4th phosphorus atom is actually in the 3rd dimension. It is in front of you, in front of the board in fact. The 4th phosphorus is around here. So I can only write it like this, 4th phosphorus. And now, so what is each phosphorus atom doing here? You can very clearly say each phosphorus is forming 3 bonds. 1, 2, 3. Look at this phosphorus. 1, 2, 3. 1, 2, 3 again. So covalency of each phosphorus is 3. Covalency means number of bonds formed by an atom in a molecule. Phosphorus is forming 3 bonds. And what do you mean by oxidation state? Oxidation state is the number of electrons you gain from others by virtue of your strength, that is stronger electronegativity, or the number of electrons you lose to others because others are more electronegative than you. For example, in a molecule of HCl, you know chlorine is highly electronegative. In some previous question we discussed FONCl. Chlorine is very highly electronegative. Therefore, chlorine wins 1 electron from hydrogen. Because chlorine is stronger. So in HCl, you can say hydrogen is losing 1 electron. By virtue of it becomes +1. Chlorine gains 1 electron, it's -1. So what is phosphorus atom doing here? It is forming all the 3 bonds with 3 equal opponents. All 4 phosphorus are equal. They are equally strong. Therefore, there is no question of one phosphorus winning and the other one losing. The PP bond is formed between 2 equal opponents, 2 equally strong teams. But here HCl is different. Chlorine is a stronger element in terms of electronegativity. So chlorine withdraws the electron, becomes -1 +1. So what about the oxidation state here? 0. Phosphorus doesn't gain any electron or doesn't lose any electron. So what is it you have to observe here? Covalency and oxidation state are 2 mutually exclusive terms. It's not always necessary that when you form 3 bonds, your oxidation state is either +3 or -3. These 2 are 2 mutually exclusive terms. Do remember this. Covalency is 3, but oxidation state is 0. How do you find out oxidation state? It is the number of electrons you gain from a weaker element, weaker in terms of electronegativity, and it is the number of electrons you lose to a stronger electronegative element. So in HCl, of course, chlorine wins over the electron and hydrogen loses, but doesn't happen the same in the case of P4. So what is the oxidation state and covalency? That question is answered. Next. What is the hybridization of nitrogen in ammonia? Once again, it is easier to say the hybridization is sp3 this or that. But how will you find for most of the molecules? I may suggest you a method which may not be useful for 100% of the molecules, but definitely you can say it is useful for more than 99%. So you just look here.